Welcome everybody to the OMUG VisionEval webinar. Let me just jump into the slide deck here. For those of you that are new to OMSC, we are the outreach arm of the Oregon Statewide Modeling Collaborative. And on behalf of my fellow coordinating committee members, Joe Broach and Leming Wang and Carol Richardson, we welcome you today. So hopefully you'll learn a lot about VisionEval and how it's being applied across the country and all the new research that's happening around it. So today's agenda is going to include some report out from VisionEval applications in Minnesota. So we've got Chris Behrens and Jill Lehman from Minnesota DOT to walk us through that. And then we've got Joe and Josh and Leming are going to cover some of the current research activities around VisionEval. And then Tara and Jonathan Slayson are going to give us a look ahead for I guess the roadmap, if you will, for VisionEval, and then we'll spend a little bit of time at the end of the meeting walking through sort of what we've got on tap for future OMUG meetings. But before we get into the meat of the agenda today, we've got a couple announcements to make. As I said, we've got a few future OMUG meetings on tap. We haven't set dates yet, but we're thinking that we're going to do a freight focus session sometime in the summer, followed up by a report out on the Oregon Travel Survey. That is been something that's been in the works for quite a while now, and folks are really excited to see some of the initial data coming out of that. And then later on in the fall, we're going to do a session around bike ped modeling and an update on some of the multimodal inventory work that's been happening. If you all have any ideas for future topics, do not hesitate to send them our way. We were happy to entertain all ideas, so feel free to do that. You can either email Carol or contact us via the website. So, oops. And then just in terms of a few upcoming events that we wanted to share with you all. There's several here. A couple are happening in May. In particular, the TRB conference on data and AI for transportation. I'll be curious to see if anybody attends that, and we'll be interested to see if there's any reporting out for that. And then just to put a pin in that Zephyr conference, the MOMO conference, if you will, that is the reincarnation of the ITM and Planning Applications Conference. And so I know folks are excited about that, and I'm sure many of you that's on your radar. And then there's an AMPO conference. The annual AMPO conference is happening in Rhode Island this year, Providence. I read a CNN article where Providence was listed as the second best town to visit in 2024. So shout out to Providence. I've never been there. And then we've got the Impact National Conference happening in Portland in the fall. So if folks have other announcements in terms of conferences, feel free to put them in the chat, and we can take a look at them or spread the word on them. Okay, I am going to then let Carol start the presentation decks. So Carol, if you will, I'm going to stop sharing. And
so I think first up is our folks from Minnesota DOT, and if you guys want to share your own deck.
Yeah, and while you are queuing it up, I'll give a quick intro to what Chris and Joe are going to talk about. So Chris Behrens, who's one of the presenters for the next presentation, is the planning director within the Sustainability Planning and Program Management Division at the Minnesota DOT. Christopher leads the implementation and development of state legislation requiring expansion project to fully offset emissions and VNT impacts, as well as development of conforming regional targets at the state transportation emissions reduction target. And then Joe is a planner in the Performance Risk and Investment Analysis Unit in the Office of Transportation System Management at Minnesota DOT, where he works on performance measure planning, risk mitigation, and data analysis efforts. Joe's work primarily focuses on spatial data / GIS analysis, strategic modeling and forecasting tools, as well as transportation equity. And he serves as a lead for MDOT's Destination Access Analysis Project. So Joe and Chris, please take it away.
Thanks, everybody. I'm going to give just a couple of context setting slides, and then Joe is going to share a lot of like how we've been using VisionEval to address some of our legislative requirements. So just to give a quick run of show here, what we're going to just cover is what we're being asked to do here in Minnesota. There's going to be a lot of parallels with some of the work happening in Oregon. We are going to talk a little bit about how we came into the use of VisionEval, and then the overall setup that we have for evaluation. So to try to just boil this down a little bit into a couple of key components, in 2023, our legislature identified a priority to reduce emissions across each sector. And so there was a lot of focus around what could be done in the transportation sector, and in particular, what could be done to be more accountable for emissions reduction in the sector. There was a couple of key requirements that were put in place. One was for us to start to evaluate emissions reduction at a more granular level and better understand system outcomes on a regional basis. And we'll get more into that, and also kind of how VisionEval has been a useful tool. We also, number two, were tasked to be offsetting any capacity expansion that was happening on the highway system. Folks are probably familiar with California and some kind of similar requirements around evaluation and assessing impacts and looking at induced travel effects from highway expansion. And so that's like a key requirement. I'll touch a little bit on this, but a lot of our focus is going to be on kind of more of this programmatic evaluation. And then as we look ahead, what we're really being asked to do, what we're being set upon, is to evaluate emissions outcomes in a programmatic way at key stages of our planning, program, and project delivery process. So what we have is, I just saw a notification. Can folks not see the slides?
Looks like we are having one or two people with trouble. So if that is the case for you, please sign out and try re-entering the meeting.
Because I think most people can see it.
Yeah,
okay.
I think you're mostly good, Chris. Yeah, we'll see if folks solve their problem by exiting and entering back in.
Okay. Here's just kind of a process flow on some of the things that we're working on, and want to draw your attention to a lot of what we're being asked to do rhymes with some of the work that you all have developed with this storm analysis and that overall process. And we want to just thank, I'm sure a number of folks on this call were directly involved in that process. We have developed a lot of insights from the work that you all have done in Oregon, and are looking to sort of apply a lot of that work. And so, but what we're being asked to do is really evaluate emissions impacts at these key stages. And right now, what we have in place is the emissions evaluation on a regional basis, which VisionEval was used to provide. And then we also have project evaluation that's happening for projects that expand the highway system, and then requirement to offset those impacts. Happy to answer questions about that, but we're not going to kind of spend too much of a focus on it. Into the future, we're looking to integrate emissions evaluation more directly into our plans and also into our program and project selection. And that's kind of a key focus for us over the next couple of years. And another area that we're going to be drawing from you all quite heavily. So, you know, don't want to try to oversimplify this, but when you think about surface transportation emissions, there's really these two key drivers when you look at the fuels and the carbon intensity of the fuels that we are putting into our vehicles, and the miles or mile rate that each of us are driving in our respective states. And these are, you know, kind of the two key levers. There's a lot going on underneath the hood, and we're going to get into that with VisionEval, but this is sort of core to what we were being asked to do. And Joe, if you want to go to the next one here, one of the things that really drew us to the VisionEval work was the opportunity to delve into a pretty difficult topic around identifying whether or not emissions reductions could be quantified from the relationship between modal options and land use choices. And this is why we saw the VisionEval tool as such a valuable thing in our process. And Joe's going to kind of get into a little bit more of the detail, but that's a little context setting on kind of why we came into it the way we did.
Yeah. So thanks a lot, Chris. Yeah, so just to start off, just want to give a little bit of a background on VisionEval and discuss a little bit more about the decision-making process to use it. So first of all, VisionEval is an open source modeling framework, which means it's quite easy to edit code and rebuild parts of the model, as well as to find help too. It's also strategic in nature. It finds answers to big questions and is able to look at policy level approach, especially to some of the larger policy decisions that we're trying to make, whether that's electrification or greenhouse gas reduction. It is a higher level of analysis for sure. So like some of the more like specific and like maybe parcel level stuff is not as included, but it is also much quicker to run, like a travel demand model. You are also pretty like able to use multiple geographies as well as aggregate up and down for this state, all the way up to the state, all the way down to the census block. You could probably do multiple states as well. And then finally, the queries are a really great way to unlock the results, and those are done in the post-processing side. So the queries make this model highly customizable in post-processing. Yeah. So then to kind of like reiterate a little bit about what Chris said about what we were asked to do, is we really wanted a model that could help us evaluate baseline future greenhouse gas emissions in 5-year increments, because that's what the legislation was pushing for, as well as looking at regional feasibility for reduction, knowing that we are a big state with a lot of different settings, geographies, and demographics, and as well as evaluate different mitigation policies using VisionEval's scenarios. And specifically the 7-county Twin Cities metro area, the Minneapolis-St. Paul metro area, must be evaluated on its own in this. So in order to do this, we wanted to break up Minnesota's geography into 3 different types. So there's the urban, town, and rural, which is native to VisionEval, that sort of breakdown. And we also used some geographical classifications for that storytelling side of it. So we use counties, which are called A zones in VisionEval, as well as Minnesota's 8 metropolitan areas, and those were each given the M area title. Is what those are called in VisionEval. And then finally, the outputs are going to be tons of CO2 equivalent, as well as vehicle miles traveled. Were the two outputs that we are the most interested in, though there are definitely others as well that come out of VisionEval. So then the next slide, I just want to talk a little bit about like how the steps to get the model up and running, the data used, as well as running the model and the output. So it all started really by breaking up Minnesota into those geographies in order to take into account like urban-rural divide, as well as just different geographical settings. And then we wanted to use a very large host of different data sets from the Energy Information Administration, Federal Transit Administration, Census Bureau, as well as some Minnesota level ones to get as accurate of a picture of current and future greenhouse gas statistics as possible. And then the VisionEval is very intuitive to set up in our studio. So we would set it up, we would run the model, we would repeat until we got like all kind of like the error messages finalized, which there are quite a few of those if you've worked with this model before. And then we also had an opportunity to rebuild some of the internal modules as well. And then finally, you run the results using like a query code, and then you can get metrics for VMT and greenhouse gas for your geography. And that's what we ended up doing right there. And a little bit about how we broke up the geographies. I just want to flash this slide real quick that there was definitely like a concerted effort into how we did this based on population, as well as the different boundaries, knowing that there's a difference between like the metropolitan organization jurisdiction and the urbanized area. And that's what this slide kind of breaks down. And if you have questions about how we did that, we can also cover those later. And then kind of just bring it back to the legislation. It was really important that we looked at regional feasibility, and we looked at the differences between different regions. And we had a couple of different approaches to do that, to break up the data, including one that is really just the Twin Cities and Greater Minnesota, one that's Twin Cities, the 7 other MPOs and Greater Minnesota, or the Twin Cities, all the 7 other MPOs, and then breaking up Greater Minnesota, the rural areas, into our 8 MnDOT districts. So I just wanted to show that, to really just show that like the ability to be have that geographical context is really a plus of VisionEval. So then we had to get some of the model inputs going. And what the model inputs include are demographic data to kind of give you a feel for the people that use the transportation system and where they live, the family size, a lot of stuff from the census, US Census Bureau. And then travel data was also used in order to see where people were going and how they're getting there. And then land use data was used to kind of give some of those locations meaning, whether that's where people are employed, or I'm saying that this is out of order, maybe. Yeah, so, but anyways, I can still take it from here. The land use data also included like multifamily housing, as well as activity centers. And then power, fuel, and vehicle data. So after you have kind of like that sort of travel inventory, how the vehicles are powered, what type of vehicle was used, was really helpful for the fuel portion of our scenarios. And then let's talk about running the model. After running the model a few times, we realized that VisionEval's projections and our projections for future electric vehicle adoption did not necessarily line up. So we were able to fix this by rebuilding the VE powertrains and fuels module using our studio's build features. And from this, we were able to input our own market share predictions from our electric vehicle infrastructure needs assessment. So I just wanted to show you kind of like the customization of this model using this, and this produced results that were more in line with the electric vehicle needs assessment. And then finally, the results were quite interesting out of this. Looking at this one in particular, we still have a gap even after all of this. We see that the gap then gets quite wider from our goal to be net zero by 2050. But kind of like having this baseline was quite important. And now we can kind of discuss and think about how we can reduce that gap. And that's where the capabilities of VisionEval's scenarios come in. So the orange dotted line is the forecast from VisionEval, and that gap is that purple shaded area. So kind of going back to one of Chris's slides, we know how transportation carbon emissions are produced. But what we really want to find out are how much would our interventions lead to a lower carbon output. So in order to do that, we wanted to break up some of those inputs by levers. So here's a list of some of the potential levers that you can look at. These are all inputs into the model, but VisionEval has the ability to have separate folders for scenario inputs, and then the model will run the scenario inputs after it runs the baseline. So you're able to change those fairly easily. And then using those levers, as we called them, we then paired levers kind of asking the same question or trying to answer, trying to find the same objective into scenarios. And then scenarios are quite easy to change. They're really just a CSV file as an alternate input. And we wanted to both test running the policy groups, so connected growth, transportation options, fuels, separately, just to see the outcomes that those separate tactics would provide, but also run them together, change around like the intensity of them in order to get a really good idea of what the model can show us and what these outcomes could be. And I think that like the number one thing that I took away from running this is that the compounding the scenarios together had produced exponentially higher results. The context that you get from not just expanding mode shift, but also expanding mode shift and having more walkable areas and more mixed use, as coupled with like the fuels, for example, really produced higher carbon emissions results. So that like coupling of scenarios was quite interesting to us, that it needs to be a multifaceted approach to lower greenhouse gas emissions. And then we also learned about what is possible for our scenarios by doing a robust stakeholder outreach, whether that's with the subject matter experts or with regional partners like our MPOs to get regional priorities and possibilities. And we also had some great best practices from ODOT and Washington DOT, who were on the forefront of the VisionEval modeling process. So to end with some lessons learned, I love the quote, "All models are wrong, but some are useful." And I think that this model has been extremely useful for us as a strategic tool. It is important to also often remember that it does not consider smaller geographic variation as much as some other models might, but the quickness and the ability to ask multiple questions, I think, is something that makes it quite helpful. And then, like I said, being able to customize it and fit the model to your data and your region was also quite important for the greenhouse gas aspect of this. Want to reiterate again that those scenario levers produce exponentially higher results when they are combined, because you get kind of both of the context from land use changing because of transportation options expanding, or vice versa. So combined, the change is quite high than running them as separate scenarios. And then building an understanding, I should say understanding, that's a typo, my bad, with stakeholders is also quite important to understand what is and what is not possible in the model, and to explain the inputs of the model. Really happy that we did quite a lot of that. And then finally, just whenever you run multiple scenarios at the same time, it is going to add time to your model. Once again, that's not, or to the model's runtime. Once again, it's not, it might add like a 45 minutes to an hour or so, but quite less than like a travel demand model, for example. So yeah, that's what we had for you all today. Thank you all for listening, and yeah, special thanks to everyone that helped us get this model up and running. Very happy with what we were able to do with it.
Okay, well, thanks, Joe and Chris. That was quite informative, and thanks for attributing that quote to someone. I've heard that quote often. I never knew who actually said it, so appreciate that as well. We do have time for questions, about 8 minutes or so. So I am going to look in the chat to see if folks want to put questions in the chat. Otherwise, you can raise your hand and ask questions the old-fashioned way. Looks like John Miller has a question. Go ahead, John.
Hey, I was just curious, the rebuilding of the modules, if you hadn't rebuilt them, what would you have lost? Or in other words, how critical was it to rebuild the modules? I get it for I think the electric vehicles you had to do it, but were other things where you had to versus, you could have lived without doing it? Thanks.
Yeah, I think that it was critical for the understanding our projections for electric vehicle adoption. I definitely don't think that it is 100% necessary unless there's a policy question that you are struggling with. I think it's very much like a case-by-case basis. There are some other aspects of the model that we were considering looking at. An example was some of the like land use aspects of the internal modules, but we decided against that because it does take a little bit of time to do those.
Thank you.
Okay.
Of course.
Thanks. Josh Roll. Looks like you have a question. Go ahead, Josh.
Yeah, thanks, Chris. Great job, guys. It's great to see VisionEval being deployed in other places. I'm curious about how you guys framed for stakeholders the amount of active transportation as an intervention in reducing greenhouse gases. And we hear a lot of great stuff about, especially Twin Cities, Minneapolis, and some of the active transportation work going on there. So curious about if you leveraged any other kinds of tools to help frame the amount of kind of diversion to active modes that you were testing in your scenario planning, and just maybe what that conversation was like.
You're saying like what else we other modeling we brought to bear? Is that
If you did, like in any other kinds of data to help contextualize, like when we've done work on some of the earlier versions of VisionEval, like you could do diversion of your SOV travel to some of the active modes, biking and scooters and what. And it's kind of easy to just say, well, instead of doubling it, let's quadruple it, or and there's no constraint in VisionEval that like prevents you from doing that. And so you kind of have to use your brain to say, well, like maybe that's not possible based on what we know from other data or analytic tools.
Yeah, Josh, this is a really great question. One of the things we were aided by was our regional planning body, the Metropolitan Council, had recently set itself upon an analysis that they referred to as the max mode shift study. And what they were trying to do is, within reasonable constraints, do some evaluation of what was feasible and trying to sort of unpack feasible with some with an eye towards providing some challenge and also being rooted in reality. And I think that was exceptionally helpful for us when we were trying to say what kind of scenarios seemed reasonable. And because one of the challenges that we run into is reducing emissions and seeing durable mode shift is not an easy thing to do, and to reduce emissions overall is not an easy thing to do. But understanding what has the most impact, and as Joe highlighted, one of the most important messages that we've been highlighting is that the commentary about the importance of pairing transportation investments and land use choices as so linked stood out in our analysis. So that was an example of us being able to sort of contextualize it against one of our planning partners. I'll try to dig it up here and drop it into the chat, the max mode shift study that the Metropolitan Council did, but that was a really helpful one for us.
Yeah, that's great. Thanks for flagging that study. That looks really interesting. We'll have to look at it in more detail.
Okay, I think we've got time for one more question. And Mark Simonson had posted a question around comparing VE results to an MPO travel model, and wondering about how much alignment there might be between the models. I know this has been an ongoing sort of conversation across sort of various regions, but did you guys do any direct comparisons in Minnesota with the travel model versus VisionEval in terms of high level like metrics like VMT and stuff like that?
We have not done like I'd say like a one-to-one comparison, but I do know that the travel demand models are definitely factored into some of the discussions that we had with our MPOs. Is what I would say.
Yeah.
And Chris, it sounded like you were speaking as well.
Sorry.
Yeah, no, I think Joe, you just covered it. That one-to-one comparison is kind of difficult.
Yeah.
Though having your models kind of talk to each other it's such a key question. One of the limitations that we have in Minnesota is that we don't have a statewide travel demand model. We only have a travel demand model in our MPO areas. The one we have in the Minneapolis-St. Paul area is quite robust, but so it presented some challenges because one of the things that we were trying to do was a statewide analysis. And so it actually provided us a lot of great opportunities to use this tool in particular. But now one of our legislative directions is to develop a statewide travel demand model over the next couple of years, and not necessarily have it be just a travel demand model, but more looking at answering kind of some of the questions that are sitting before us in our state and in many others around multimodal system outcomes, and being able to do that type of integrated analysis and comparison across models. We're keeping a close eye on that research effort from that was put into the IIJA bill to improve the modeling validity of travel demand models, and that there's a research effort by University of Kentucky that is helping with that, that we'll be keeping a close eye on. I bet a lot of folks on the call know what I'm talking about, but that's going to be closely watched by us.
Okay, thanks. Well, yeah, great job, Chris and Joe. Really appreciate your participation here. But we need to jump to the next topic, which is Laming's going to catch us up on research around the land use. And before you start, Laming, let me give the folks some background about you. And so Laming is an associate professor of urban studies and planning, urban and public affairs at Portland State University, and a member of the OMUG coordinating committee. He currently works on a project funded by the National Institute of Transportation and Communities that investigates approaches to integrating land use and transport data from diverse sources to enable modelers and planners to rapidly incorporate new data in their models and analysis. So Laming, take it away, please. So Laming, if you are speaking, I cannot hear you.
Can you see my screen?
Yep.
Oh, okay.
We're
good.
seeing, Laming, we're seeing your raw presentation covered with a
Okay,
notes.
I will put it on the full screen.
Perfect.
Okay, is it work? Okay, perfect. Cool. Right. So we I will be talking a bit different than what Chris and Joe's talk about a actual application in Minnesota. I believe Josh and Joe's following mine will be as well be on the research track of VisionEval, helping hopefully make VisionEval even better than what it is. So I will be talking about a new V land use module that myself and other folks at PSU, along with Brian Greger, has been working on since 2024 or 2023. So why we want to do that? Many of you probably familiar, or at least came across this flow chart or diagram before. So this is the VisionEval model step of using RSVM as an example, that there are a number of different packages, captures, model different aspects in the urban system, that affects travel and then GHG emission. So in the dash box is the V land use package, along with other household vehicle, transport supply, and other packages that interact and work together to produce the predictions. So the particular V land use module, they have two different flavor. That the Minnesota example, that application that Chris and Joe mentioned, they're using the V state flavor. Those will be the corresponding to a land use module that's only right there, called V sim land use. So the reason that we need to have two different flavors is because the current VisionEval land use module require users to provide input at particularly land use input at very high level specificity. So it means B zone level housing units, as well as employment distribution for not only the base year, but also the future year. Since that's pretty challenging to do for a state or a larger scale geography, which is why we use a so-called SIM B zones or synthesized B zones. That is a combination of development type, as Chris and Joe talked about in their presentation, and then the more finer resolution, the VRSPM version, that we have a more physical actual B zones. Those at right now most applications corresponding to the census block group. So, and then in that case, the user do have to provide all those housing units by different housing type, as well as the employment by different sector groups at a B zone level. And so, of course, it has its kind of usefulness, or and this is the how current V land use module works. So in that case, you do have some confidence, or you can test a higher number of scenarios, how those different distribution of housing units, employment land use scenarios, how would that affect your GHG and other travel performance. You can certainly do that. But the downside there is that you have to specify those. What if you have uncertainty in terms of how land use will develop? How will that interact with the transportation policy that you put together? So, which is exactly the goal of this project, is trying to have the land use module captures how land use responds to transportation investment, and then improve the support for land use scenario. And then at the same time, trying to address the V state lack of basically spatial details. Of course, it has the advantage of V state configuration is that the computation will be faster, because the current configuration is that you combine those synthetic B zones. You don't have to go over all census block group in the state. Imagine that for a larger state. And this is still ongoing. We are close. We are about less than 2 months till the end of a project sponsored by Oregon DOT through a SPR project. And more specifically, in terms of the objectives, I believe those are the 6 I can think of. So the first one is trying to replace the synthetic B zone in V state with a real geography. Of course, hopefully still keep the option of using a larger geography to speed up the computation. But down the road, looking into the future, if we could figure out ways to improve the hardware requirement and running time, we could potentially have just one model. Okay, and then second objective is to support applications at different scale and level of specificity. So I mentioned that the current V land use require you to basically provide those land use input at a B zone level for RSPM, and then for V state, the B zone will be basically all those different place types. So of course the new module will still support that type of application, what we labeled as use case 1, or as we have jokingly mentioned, those are the God mode of VisionEval, because you can dictate where those land use development goes. And then we support two more use cases, two more types of application where the user has less specificity for land use development, particularly in future years. Use case 2 allow the user to specify B-zone land use type as well as target by land use type. I will give you a little bit more kind of detailed diagrams later. And the last use case is that the user be able to just allow the model to predict what the future B-zone land use type will be, and then specify the target that's at either at E-zone or at land use type level. Third objective is to make the B-zone allocation for housing unit employment sensitive to transportation infrastructure and service. Right now, again, those are the current V land use can only or require the user to specify those at a B-zone level, so they are not necessarily corresponding or responding to those inputs. And then in addition to that, we want to update to use the latest data because the last iteration rely on the 2001 data set that Brian and other put together. So it's time for a update since we do have better and later data that's now available. And then two more, and then we try to explore other algorithms such as machine learning that could potentially works better than some of the traditional methods, especially for cases where we do not need to have a very good explanatory understanding of how the actual model works. We only focus on the prediction accuracy. We'll give you an example on that one. And then hopefully the new module will be just a drop-in replacement for the current V land use and V sim land use module. Give you a little bit kind of overview of the land use type or the what they are, and then because right now in the new module it will be a more central concept for specifying the land use scenarios and as well as other applications, other type of applications. So the land use type is basically a concept we adopted from the place type in the current V state model. And it has 3 dimensions, including the, of course, originally called the development type, but we again largely avoid confusions. We renamed the place type to land use type, and then the development type to diversity type because it's basically measuring the mix of residential and employment. So we have residential, diversity type, employment, and mixed use. For area type, those are exactly the same in the V state place type, including center, inner, outer, and fringe. And finally, neighbor location type. I believe Joe and Grace's presentation mentioned those as well. So we have urban, town, and rural. And for diversity type, also give you an example of how we use basically machine learning, in this case decision tree, to help us kind of coming up with which variable to use, as well as where to set the cutoff. Okay, the V state, I believe Brian did the original research to come up with cutoffs for the V state place type. It's still lack or haven't gone through a more comprehensive analysis of where to set the cutoff. Okay, so in this case, we choose the D2, so-called D2A from SLD, Smart Location Database, using the variable job per households within a 2-mile buffer. And then here in this example, we basically divide those 3 diversity type based on that one variable. If that value is less than 0.3 per jobs per household, it will be classified as residential. And then if it's between 0.3 to 1.2, it will be classified as mixed, and so on. Okay, and finally, and another, will not go into detail there. We use a similar approach, a similar method for the area type definition as well. Here we differentiate between large urban area and small urban area. For location type, again, another example there. We originally think we could just utilize the Census Bureau urban area data set, but unfortunately they changed definition from 2010 to 2020. Also in 2020, they get rid of basically the urban cluster, the town classification. Which means we will not be able to directly apply or directly use their data for V land use, for this new V land use module. So what we end up doing is we use the 2020, we use their 2020 data. We add the urban cluster back because it's relatively straightforward thresholds. And then we crosswalk back to 2010 census geography. And then we use this data to train a random forest model. Here, we used random forest instead of decision tree because it has better prediction accuracy. At the same time, this is a process. We don't need to actually understand or be able to explain how the actual model works. So we are fine to just aim for the prediction accuracy. And then we apply the trained random forest model to predict the location types on 2010 data. So we have a consistent definition for those location types. Rather quickly, show you on the upper left, those are observed urban rural classification in 2020 from census. On the lower left is the observed urban rural classification in 2010. As you can see here, there are quite a number of blocks for Corvallis. Use Corvallis or Oregon as an example there. As you can see here, that there is quite a bit of census block were urban in 2010, but they are rural in 2020. I cannot imagine those are what happening on the ground. Those are just largely the artifact of the changed definition. So on the right there, the two top and bottom, we have those reclassified based on the algorithm we trained. It also has pretty good prediction accuracy in the 94% and higher. Okay, I do not expect you to be able to read this. Also, it's sideways, so I can fit it in the slides. So those are all the data set that's used in this new V land use module. It has a number of them. Each circle here represent either a raw or intermediate data set. So we use a so-called data pipeline, so to keep track of whether the data needs to be updated and so on. So a list here are some, most of the nationwide data set we utilize in this new module. To go through a bit on the application use case. So the use case one is basically the current V state. The user provide B-zone level housing unit employment. The model basically assign households based on the housing unit counts. At B-zone level, assign different house type, and as well as match employment to household workers in the household match to their employment B-zone. The output will be households and employment, workplace, or assigned to a B-zone level. And then in terms of the second use case, it's a little bit more flexible than the first one, is that now we will be able to allow the user to provide not the housing units and employment by B zone, but just what the future land use type of a B zone or each B zone will be. And then the user can provide what are housing units and as well as employment by different B zones for future years. Okay, and then the model basically allocate those housing units, households, employment to those B zones. The end output will be exactly the same as the first use case. Third use case is most flexible, that allow the user to basically provide just base year B zone land use type, and then the housing unit and employment either by land use type or even potentially by A zone. And then the model basically predict the land use type, B zone land use type for future years, and then allocate household employment to B zones. Okay, and then we do also have I think it was a cool idea. I believe Cody Mayer from DLCD is the one that proposed this use case. Is that on top of use case 3, that we could output the prediction probability, and then use that to figure out where are the so-called high leverage location will be. It could potentially be transitioned or upgrade to a higher intensity land use. And in terms of the status, we are finished the last bit of the pilot testing, and then finish the report. And then those report and code will be available only by the end of June, which is the end date of the project. So it's only looking forward to have you all poke around and potentially even use the new V land use module in your application. I want to acknowledge the help for a number of people, the support, of course, from the ODOT SPR 868, Brian Greger, advisor for this committee, for this project, and Josh Rao as coordinator for the project, as well as the TAG advisory committee for kind of helping guide the project throughout. With that, I will answer any questions you may have. Thanks.
Okay, thanks, Leming. Yeah, we've got several minutes for questions. So like last time, if you have a question you just want to ask, feel free to raise your hand. Otherwise, feel free to post it in chat, and I will monitor the chat. Oh, Leming, can you see Haroon's question in the chat?
Yeah,
it's a longer one. Do you want me to read it, or you just want to answer it?
Why don't you read it? So I
okay, so Leming, your project objective to connect land use and transportation policy is very promising. Ultimately, do you want to analyze induced demand scenarios, which frankly was something that popped into my head as soon as you went through that slide? And then how does land use change to transportation infrastructure development due to infrastructure development? How can that produce completely new trips on the system? So this is all about induced demand.
Right. Yeah, that's a excellent question. Right now, of course, the current V land use only would not capture any induced demand. The concept that basically you provide transportation infrastructure, be it highway expansion or transit, or for that matter, bike and pedestrian infrastructure, that basically providing those will promote or will allow households employment to relocate, and then those relocation will create new demand for driving, transit, or other modes. So because the current specification basically require the user to provide those land use as input, not only for the base year, but also for future year. So basically, unless you can anticipate, you can directly model those output in your input. Otherwise, it's almost impossible to capture. With this new V land use, it will, to some extent, capture those, because in the household and employment allocation, we do take into account those transportation investment, transportation infrastructure and policy. And so those will be captured to some extent. I do not, of course, we haven't assessed, it has not been applied or assessed for induced demand per se, but theoretically, I believe it will capture to some extent. But what I do not know, I cannot say at this point is to what extent it will be sufficiently captured realistic induced demand in the new V land use module. Excellent question.
Okay. Thanks, Leming. So Jonathan Slayson has a comment. So Jonathan, did you want Jeremy to talk about the travel cost index module, or did you want Leming to talk about that?
Well, I can give a plug to Leming and to Jeremy.
Okay.
But because during the past VE pooled fund that Jeremy was helping administer, there was an effort to create a beta module that put into practice some research that Li Ming did. So Li Ming, maybe you want to describe, because I think the conversation about induced demand or induced travel, Li Ming's capturing the land use aspects here, but then obviously if we make a big physical infrastructure investment, then that will result in the interplay. So it's the land use and the infrastructure side. So there is a beta module that's been developed that attempts to put into practice the transportation cost index. So maybe Li Ming, you can just quickly just say what that is.
Right. Yeah. So the idea is trying to not only, because when we talk about transportation costs, we generally think about what are the monetary costs, out-of-pocket cost for each trip paid by traveler, including parking cost, including the for fare for transit, including the insurance and gasoline for driving and so on. But what's missing there is basically the time cost component. The idea, I believe Brian, and now I'm blanking on his name. Metro are the two. Yes, exactly. But Reeve is the other person that in collaboration they proposed the idea, and then we did a later project trying to update and then have it work using conventional travel demand model data, and then trying to combine or collapse those into, you can imagine it's basically a generalized travel cost, and then index those so we can measure them and then use it as a performance measure. So what Jonathan mentioned is that those will be incorporated, I suppose, in the future or in a probably current ongoing VisionEval module that will be able to capture the transportation cost. And then what could happen is we may down the road, once we have those module working, and then we could come back to the land use module and have the land use module capture that how when travel cost index change, how land use will change in response to that, and then it will better capture the induced demand that way.
Okay. Thanks, Leming. Thanks, Jonathan. So we have time for one more question. Anybody has one? If not, we're happy to move on and get a bit of a head start on our next topic. All right, going once, going twice. Thanks, Leming. Appreciate it.
Thank you.
Okay, next up we have Josh Roll and Joe Broach. Josh Roll from ODOT and Joe Broach from Metro to talk about and some bicycle research that's ongoing. And while they queue up their presentation, I'll read their bios. So Joe Broach, PhD, holds dual appointments as senior researcher and modeler at Metro, as well as research associate at Portland State. During 15 plus years in transportation research and planning, his work on non-motorized transportation modeling, behavior, and data has been widely published, incorporated into federal guidance, and incorporated into regional travel models, including Metro's class-leading bicycle demand model. And then Josh Roll is the research coordinator at Oregon DOT's at the Oregon Department of Transportation. Sorry, and he focuses on bicycle and pedestrian safety, decarbonization, and equity. Josh specializes in data analysis and modeling to evaluate travel costs and benefits, aiming to guide investment decisions that will improve traffic safety, reduce social inequity, lower emissions, and improve health outcomes. So welcome, Josh and Joe. Please take it away.
Thanks, Chris. Give me 1 second here to get this working so I can see you and the presentation. Always the trick. All right, here we go. Well, almost. We'll just go with it as long as you're seeing my slides. A little funky for me. Okay, well, yeah, thanks for having us. I'm Joe Broach, as introduced. I have Josh Roll with me. We do not have our third instrumental researcher in this research, Dr. Christy Kearns from University of Arizona. Worked on all aspects of this project, and it's sort of my pleasure to take us even farther out on the research branch of VisionEval before Tara and Jonathan kind of bring us back to the main stem. So I think this works pretty well. But I thought, it was interesting work. It's not in the mainstream of VisionEval development, but I think it's a good example of how something with this amount of buy-in and flexibility, as I think the Minnesota folks set up nicely earlier, it provides a nice organizing framework and kind of catalyst for connecting research to applications. And that's always a challenge. So a touch of background on this work. It was originally conceived as an ODOT research statement. It didn't get funded through that process in the end, but we were able to find a way to fund it through the PSU NITSE Technical Transfer Grant, which tries to connect emerging research to tools like this into practice. So I think it's a neat example of a lot of coordination and collaboration to do some advancements on the research side with an eventual end goal in mind of making it into the functional VisionEval. Most researchers, I think, would take a track like this. There are a few. Dr. Liming Wang is a singular force in that he can take it from research all the way to module. Most of us on the research side are more likely to stop somewhat short of that, but if we have that as an end goal in mind, I think, as you'll see, I think that's really helpful to make sure that the future development stream is set up to get this into a usable tool. So with that, let me get started. So this was where we sat, and a reminder, this was several years ago, and so we were looking at a somewhat different VisionEval than there is today, but I think some of this is still relevant. And the sort of problem was mentioned earlier when we were talking about that maximum mode shift study, that VisionEval sort of treated these active travel modes as exogenous inputs. You asserted there would be a 5% bike share, a 10% in a future scenario, or some level of diversion. And of course, we know that's not really how policy works. We're usually setting goals in terms of projects delivered or network improvements, for instance. And there was no way to connect that directly. We had to assert the outcome instead of the kind of policy inputs. And it gave us a kind of an awkward lever sometimes to talk about. So we were also really excited. At that time, it was really hot off the press, but some of Liming's earlier work to build this VE multimodal module, which had proposed and tested ways of disaggregating that somewhat, or bringing it up to a different level where transit, walk, and bike travel were sort of directly estimated and then entered the flow of the VisionEval modeling and fed into household VMT from the front side instead of the back side as a diversion. But still, there was no direct measure of bicycle networks, and we sure don't blame Liming for that. It's a challenge. V doesn't have a sort of native network concept in mind, at least in the main stem and at that time. But there was a lot of emerging work on the research side that we felt could connect to this, and in particularly around bicycling and the impact of network accessibility and quality on where and whether people choose to ride bikes and at what level. So in our conception of this, household VMT would be reduced directly or more or less directly given improvements in bicycle network access and quality. So we operationalized this. We went through quite a few iterations and had some great input from some folks in this room and some others. But in the end, it was pretty simple conceptually, but as you all know, that doesn't mean it's simple in practice. But the idea was to combine bicycle network connectivity, which we knew quite a bit about. And then, of course, you need opportunities for that to actually translate into useful connectivity. But the combination of that would give us a network-based sort of household-level accessibility by bicycle. That would be mediated or moderated. We tested it kind of in both concepts by the context that household found itself in. So you've got a network, there are some opportunities along it, but then the rest of the built environment, the demographics of your household, even things like bike ownership, or just willingness or showing a willingness to bike at all or play into it. Luckily for us, and this is why I mean VisionEval is so useful as kind of a catalyst or an organizing concept, is that a lot of that work in the bubble had already been done, and we could just build from that, from Lemming's VE multimodal module, which had some nice functions to directly estimate household daily vehicle miles traveled based on a range of contextual variables, but not the bicycle network or access. Out of that, we thought would come sort of a bike diversion potential that would kind of upfront divert some household deep VMT away from driving and towards cycling, with the idea that was built on this framework of improved network access for bicycling. And we thought this could come via in two ways. I'm sorry, it's A and A. That should be A and B here, but there was a direct path that we thought it was less developed in the research, so we were a little less confident that we could get there directly, and that would be that household daily vehicle miles traveled was a function of all those base variables I was mentioning that were already in the module, plus a bike access measure. So in other words, improvements in bike accessibility on a network would directly reduce household VMT. That's a less settled issue in the research literature, but we wanted to test it because it's a nice, clean way to go. The second one we proposed was kind of an indirect reduction of household VMT based on bicycle access, and that was via the number of bike trips a household was expected to take. This concept, bike trips as a function of network accessibility, was a much more established concept in the research. We felt more confident that we would get there through the indirect route, but we wanted to test both. So just to reiterate in this conception, the household VMT would be reduced sort of via the bike accessibility's impact on household bicycle trip making. So households predicted to make more bike trips, and then that increased number of trips would feed into a household VMT equation, hopefully on the negative side. Hopefully that's clear. I know this is a lot, but you don't have to think in terms of formulas to get. It's a fairly simple concept, but it takes a bit to put into operation. So the big question, of course, was what do we use for our kind of summary measures of bicycle access? And we identified three candidates for this proof of concept testing. One of them was People for Bikes Bicycle Network Analysis Index. This is available nationally. It summarizes access. It kind of works like the consumer price indicator, where you have a basket of goods and the prices. In this case, you have a basket of daily destinations that you want to reach, like grocery stores and schools and other amenities, jobs as well. And how much of that basket can you access via a low stress network? For those unfamiliar with level of traffic stress, it's just a very simple concept, 1 through 4. And as the numbers get lower, the idea is that more and more people would be comfortable biking on that level network. So for this one, you end up with a census block level score normalized 0 to 100, where 100 is you can reach every destination on an LTS 2 or better access, which for most adults is considered comfortable. The second measure we looked at was the University of Minnesota's Access Across America bike measure, which is it's related to B&A, but in this case really focused on jobs in different categories and within different access sheds or travel times. It's the full measure is only publicly, at the time, was only publicly available in 50 U.S. regions. They may have expanded that by now. I've not been super connected to the work, but the base measure was available in all urban areas in Oregon, and that one is just a general access to jobs measure. So again, available at census block level within urban areas. So we tested that one as well. And then a final one I've been involved with and is closely related to Metro's regional bike modeling, which is Portland State's Route Quality Index. And this is a revealed preference-based measure that essentially normalizes to kind of like a standard facility and then goes up and down from there. So it ranges from 0 to can even be over 1 if it's better than like a plain bike lane. But it again is kind of summarizing the expected quality of access to jobs via bicycling network. It's available in its native form at the census block group level, but based on some lower level destinations. And I'll talk about it a little bit more as we go on. Just as an example, here's Portland and Eugene, and these are the B&A tool, that first one I mentioned. This is its summary of access, again, from 0 to 100, with the warmer yellows there are higher levels of access to destination via low stress bike networks. The cooler areas are poorer, and I think the pattern of it has that typical level of traffic stress look, where you get kind of islands of connectivity and disconnectivity because of the way it operates. But you can kind of see the nice thing is it is a standard way to measure across lots of different areas, Portland and Eugene, sort of shown here. Quickly take you through the key data we used for this. Again, proof of concept. So Lee Ming's work on the multimodal module used the NHTS data for household VMT and demographics. We relied on the previous Oregon household activity study, the statewide household travel study that was done in 2010, 2011. And so we took just the VMT on that survey day as being representative, again, just for proof of concept. For built environment, we tried to match the smart location database variables that had been used before. And then I showed you already those sort of 3 measures of bicycle network accessibility that we were going to test. So let me show you the first round of results. So this is that direct pathway. And to be honest, we were somewhat surprised, pleasantly so, that we saw when we modeled household VMT and included these summary measures of bicycle network accessibility, we saw a significant negative impact in that base model when we added bike access to the base VisionEval multimodal estimation model. And it was, while it was inelastic, right? You see that a 1% increase in B&A yields a fraction of a percent increase in decrease in VMT, but it's still meaningful. And you see below kind of a written out example that I think is nice to have in mind. So sort of improving the B&A, the access score, by 25 points, which is about the difference in average conditions between Boise and Eugene. No shade intended to Boise. Would decrease household VMT, we would expect, by about half a mile a day. Higher for bike-owning households, if you were able to identify them. Another way to think about that, that's replacing about 1 2-mile trip for every 4th household. And to us, that struck us as kind of a plausible, actionable, useful level of diversion, which is always a good sign when you're testing some new models. As I said, the impact in bike-owning households was considerably higher, about 2 times, and we used bike ownership as kind of a proxy for willingness to bike some, right? So in a sense, we use that as a way to proxy for that willingness to bike. One interesting point is that when we pulled in the kind of broad access to jobs measure from the University of Minnesota, so this is on an all streets network, how many jobs can you access in 20 minutes by bicycle? The fit was improved, including them both. They were jointly significant, but it did diminish the impact of the pure bike quality access measure, which suggested to us that maybe there's some work to be done, and maybe it's already in progress on just kind of a more general network-based access to employment measure in the mainstream of the VE multimodal module. So anyway, keeping that in mind, we were still pleased with that initial result. We still wanted to test the indirect pathway where bike access impacts household VMT via an increased probability of taking bike trips. And indeed, the access measure was had a larger marginal impact on VMT when predicted via this bike trips pathway. And in particular, bike-owning households were surprisingly sensitive to network access. And, it suggests there may be a subset of households or population that is going to really respond to this type of network improvement policy. And there may be another group it's going to take a lot more in terms of context to respond to these sorts of future projects. But there was actually an elastic response, so about a 2.5% daily VMT decrease per 1% improvement in that summary bike access measure. So worth paying attention to. Some definite caveats here in the model form was fairly basic. And I'll link to the report at the end for those who want more details on that. We don't have time to get into all that today, but I think overall, again, kind of as expected, this connection between network accessibility and bicycling activity or trips is still kind of the stronger one. There are a lot of intervening factors, I think, that we can't control for between bike network improvements and direct reductions in household VMT, right? But both seem useful and worth pursuing. And finally, we also did a little testing just in the Portland metro area where we had a kind of a richer data set and a little more to work with. We had the PSU measure available. It requires a metro style network. We also had the full suite of the University of Minnesota bike access measures available. And interestingly, in Portland Metro, it was only that University of Minnesota measure that was significant via that direct pathway. In the indirect pathway, all 3 were useful, significant, negative impacts on household VMT. And maybe no surprise because it's kind of tuned to the population in the Portland region, but the PSU Metro style route quality measure had the highest sort of marginal impact on VMT, and it picked up the strongest effect. That one would be challenging to expand nationwide. Maybe less so in the Oregon context, though. We've got ABM development, some other things Josh is going to mention that might provide some additional test opportunities here in Oregon in the near future. So excited to see where this goes. But as I hand it off to Josh to talk about how you might use these initial results and to take us into the future a little, I think worth repeating that we found this really useful just way to organize our ideas within the VisionEval ecosystem and kind of connect some of this emerging research to useful tools. Pass it over to Josh now to talk about how you might use this now or in the future.
Thanks, Joe. Yeah, so I'm here in the research unit at ODOT, and we love model systems, because we can take research, and instead of just, writing a paper or a report and sharing that, we can put these findings into practice. And so the VisionEval framework has been great to as a home and destination for great research. The work that we did, and a lot of that, most of it was done by Joe and Christy. I was helping out with my time, but the project was generally pretty small project in terms of overall funding. So Joe's already said this, we weren't able to get it all the way to a usable package for VE, but we wanted to try and think through how the findings that we created and developed could at least be useful until we are able to kind of move it over the finish line, get it into a package, do some more testing, and get it fully integrated into VisionEval. So, some of the things that Joe's talked about with the elasticities, we thought about deploying the findings as kind of a sketch planning tool at a regional scale where we can kind of test a little of those effects from, for the BNA tool, considering how we might what amount of VMT reduction we might see if a certain number of households are placed into a zone with higher bike access. One of the things that we did was just apply the model and do some counterfactuals and some scenario simulations, kind of what we would do in a full integration with VE. Ideally, we can get to a stage in this third bullet point here where we're actually going through changing network links, maybe bringing in bicycle master plans to inform what links are changing, recalculating those accessibilities on low traffic stress networks, and then applying those to the households within those areas and playing out how this works for VMT reduction. Joe, if you want to go to the next slide. For those scenario simulations, we took a shot at this to say, in households, in the data we have, the household travel survey data, do this counterfactual and see how it actually plays out in terms of overall VMT reduction. And for the folks who've been doing VisionEval applications, I think it's clear to see that in order to meet our goals for overall state targets, there's no one silver bullet, that we have to put together a package of interventions. And so when you're looking at those elasticities and you're saying like, well, boy, like a few percentage point reduction in VMT as an effect from higher bike access, that doesn't seem like a lot. But when we play that out, we simulate this using our household data and our travel surveys, you can see that if we drive a lot of the households to higher bike access, we actually get a relatively high effect, in the 2%, 3%. And, if you really push the envelope and put a lot of households in high access, you get a relatively high impact in terms of household VMT. And so that's what we're trying to show here. Looking at the different models, those are the different colors. Pushing, like if you look at that medium or high section of the bar charts, looking across the different models, looking at maybe 4% VMT reduction if you're able to get a substantial number of the households into places that have medium level bike access. And so, what it would take to get there is still one of those unanswered questions. What amount of build out of low traffic stress bike networks would be required to get there. That's a bit of the missing piece that when it comes to VE, where you're able to actually put in per capita miles of transit service or put in per capita amounts of arterial expansion and kind of see how those impact VMT. That's a step that still needs to happen for this to be implementable into the VisionEval framework. But as Joe mentioned, this is a lot of proof of concept showing that these relationships exist, that advanced, I think, our understanding about the role of bike infrastructure in VMT and subsequent emissions output. And so, Joe, if you want to expand or go to the next, we're really excited about the data that's being developed and that we're beginning to get access through. We have the new travel survey for Oregon, 44,000 people, 22,000 households. Half of those recorded their trips using the smartphone application. So we're going to get detailed route information. And we're hoping that we'll be able to pair that with some of the data being collected in the Oregon urban areas through the CFEC multimodal inventory. So that project is aimed at collecting high quality bike and pedestrian infrastructure data across the state, at least in the MPO areas where most of the bike and ped travel's happening. So combining those travel survey data with that high quality infrastructure data and computing some of these measures of access to jobs and other opportunities on low traffic stress networks, I think will allow us to build a much more refined tool that would be able to integrate into VisionEval and give us a lot more understanding about, just how much bike infrastructure is required to meet some of those SOV traffic diversion targets that we've previously been using as an input into VE. So we're excited about the future. We think this has been a good proof of concept to help us understand some of these key dynamics between access and VMT generation. If you want to go to the next one, Joe. And yeah, just acknowledging funding from NHTSA and Portland State and ODOT and Metro funding some of Joe's time. Alex Bagazi from UBC helping with the original research proposal that led to this work. And then the review from Brian Greger and Jeremy Raw and Tara Widener and Dr. Wang and Leeming's work at PSU, who's, as we just heard, doing a lot of great stuff with VisionEval. So their review and guidance was really helpful for this work too. So we just want to point that out. Happy to take questions with what time we have left, Chris.
Okay, thanks, Joe and Josh. Great stuff. We do have a few minutes, I think, for some questions. Again, if you have a question, feel free to raise your hand or post it in the chat. And Alex has a question. Go ahead, Alex.
Yeah. So with the extra VMT reduction, if the household owns a bicycle, I missed. Is the intent that would be a synthetic household input, or would that be represented, or were you just kind of showing how that impacts the overall average? Anyway, trying to understand if that was going to be if that was intended to be a VE input at some point.
We essentially included it to see if it would be worth pursuing, exploring as potential. And we don't see it necessarily as being like a bike ownership model embedded, but it was the closest thing at hand to kind of getting at this more attitudinal, types of cyclists kind of concept that has been bubbling around a lot of our work. I think we all want to get something like that in there because it seems like it makes the policy more realistic to people. A lot of people say, well, if you say there's going to be a blanket X% increase across households, we know that's not going to happen because there are some that just won't respond, right? So that was our thought, and I think the answer is yes. It does look worth identifying those if you want to do a better job of understanding where the impacts will be or where the highest payoff would be. So yeah, not saying you have to have it, but it does look like there would be a good return on kind of investing in some way of pre-identifying those households that are more sensitive to bike improvements. So I know that's a roundabout answer, Alex.
And it's it's our hope to try to classify households and even persons within the households that may be impacted differently from different build out of networks. Alex, I've talked about this a lot, that you build a high quality network and it's still not going to matter for a lot of people, right? But for a lot of other people, the strong and fearless, right, it would probably have a much higher impact. So if we ideally, you could categorize different classifications of persons or households, and then the build out of the network, as we try to connect some of these analytics, you can better understand just how much more either traffic diversion or biking, depending on your metric, you'll get based on where the person in that household is starting from. Because some people are just not going to be interested, but others, your network interventions are going to be much more impactful. So this is maybe a little first shot at trying to understand that too.
Cool. So yeah, it sounds like still
Yeah.
kind of like an unknown area of exploration. Yeah, go ahead.
Missy, we're almost at time. Let me do a lightning response to a couple of the ones in the chat, and then I
thanks, Joe.
can respond to others in the chat too. But to Thor's question about, the elasticity seem low. Can we make the case? The one neat thing is that these are not these measures can move quickly. It's not like, that's the advantage of the network. You get that network leverage. So if you close a single gap, you can sweep the scale on this one of these bi-axis measures quite a distance without having to do like a miles of bike facility measure or something that's extensive and takes forever. So I think that's the quick answer there, is that though the elasticities are low, the the underlying value is very policy sensitive. You can move it quickly. To Jonathan's question there on how many bike lanes, where to put things, or prioritization. I mean, this gets to the question of that intersection between VisionEval and RSPM and regional scale travel models, right? And at that point, I would be tempted to say, if you're like Portland Metro, you'd probably be better off using your in-house travel model to do something like a priority. But it's not to say you couldn't do this. Like Josh said, all of these measures are open source, well documented. You could reproduce in different scenarios if you had the network analytic capability, and test some scenarios and see where the biggest impact on those accessibility scores were. And I'll hand it back over now in the interest of time, but I'll try to answer a few of these other good questions I'm seeing in the chat as we go along. Thanks for having us.
Okay, great. Thanks, Joe and Josh again. And taking us home, we have Tara and Jonathan, who are going to give us a look ahead for VE. And while they are queuing things up, I'm going to give some background on both of them. So Tara Widener is the Climate Impact Analysis Program Lead within ODOT's Climate Office. Tara supports ODOT's Climate Office in a variety of data and analysis efforts, including greenhouse gas scenario planning and targets, adding a climate lens to state funding decisions, and other climate actions in coordination with a broad mix of state and local partners. Tara has over 25 years of public and private experience in modeling and analysis of multimodal transportation system. Her career is focused on quantifying the complex interactions of transportation land use and the environment. She holds a bachelor's and master's degree in civil engineering from Purdue University, Boiler Up, and the University of Cal, Berkeley, and is a registered professional engineer. And Jonathan is a PE and imagining consultant at RSG. He has provided professional engineering and planning consultant services to public and private clients for over 20 years. He has worked both nationally and internationally on land use, policy and planning, design projects, and more recently, long-range planning, emphasizing climate and equity goals. He leads RSG's strategic modeling practice with a focus on exploratory scenario planning. So, Jonathan and Tara, please take it away.
Y'all can see my screen, correct? Tara, you're raising your hand.
Yes.
Just want to jump in and say we're going to hear from Jonathan about a few more applications, bringing this down to sort of reality of plans and programs that we're actively working on now from the research realm that we've been in. And then I'll wrap it up with some more conclusions at the end.
Great. Thanks, Tara. Yeah, it's really great to hear all the innovative research and pieces where the tool's moving. I have 3 applications that we've been involved in as of today. So these are very real applications that we wanted to highlight and just show some of the flexibility and some of the new use cases that we're seeing. So Southwest Washington Regional Transportation Council, I think we had somebody on from there. This is an example where this is an iteration and an evolution of an existing VE model. And this is exciting because for at least our awareness, this is the first time that the model has been built for one application. In this case, Portland Metro, who there's a lot of folks here, and Teo was involved in the development of the original model. It was designed in a way that it was encompassing of the commuter shed, which is great. That's the way it should be designed. But it included areas north of the Columbia River that was outside of the jurisdiction of Oregon. That was really why the model was being built for. And so now the state of Washington has legislation, HB 1181, that talks about VMT targets that different regions and counties are supposed to consider how to achieve, municipalities or jurisdictions are supposed to achieve VMT per capita reductions. So comp plans need to account for that in their Growth Management Act. And so VE has been identified as a resource that these communities can go to start to identify all those different levers of how to achieve those VMT targets. So in this case, we started with a more or less a good detail from up here in Clark County, but we've added 120 new B zones into the geography, added a lot more resolution to it, and we're in the process of verifying all the inputs with that additional resolution. The nice thing is that eventually the two models Metro can decide to keep their model intact as it is, or do they want to benefit from the additional resolution north of the river if they want to account for all of that. So there's going to be that decision later on, but at least it's all merged on GitHub, and it can be tracked as to how the model evolves over time. The other benefits of this is that for the Washington context, we get to replace the powertrains and fuels package that Joe mentioned. And so Dan Cody, I'll be knocking on your door here soon enough as we try to get agreement on how we want to represent the Washington expectations for those vehicle sales. An example of a process that we carried out to try to start the scenario planning is that we did a Mentimeter activity. I wasn't there in the room, but we had about 30 folks from a call, and we were able to dive in and ask questions about the types of levers and exogenous uncertainties that they were interested in exploring in their scenario planning process. Some of the things, this was just one example of the local transportation actions, but we explored land use and policy topics as well as those outside exogenous factors. So some of the things that came high priorities were the increased active travel. We saw transit coverage. They were interested in some parking. They were less interested in the congestion fees and tolling type of topics. One things that were exciting to see is that they were interested in exploring the land use density, diversity. They were also interested in exploring some of the exogenous uncertainties, such as the aging of our population. How is that going to affect our travel behavior? And so we do see that transit declines in interest, particularly for older populations. So it's going to change our travel demand. They're interested in exploring some of the uncertainties around autonomous vehicles. We're seeing that increase in I guess, prevalence, or at least it's showing up more in my news feeds more and more about connected and automated vehicles again. So, so those are things that we'll be exploring with them in their scenario planning process. Another shifting a little bit further east is central Indiana. We have two MPOs decided to conduct VisionEval models together. And because they're part of one larger Indianapolis commuter shed, it was really important to do a deep dive. We're using LEHD data on the commuter sheds, to understand how many of those workers, where do they live? And so we had a bunch of analysis that was done, and this shows the metropolitan planning areas on the screen. But what I don't show here on another is that we built the VisionEval model to kind of from my cursor over here all the way over and down. And so a big square around this area so that we were able to capture and try to maximize really the internal capture, the number of folks who both live and work within that model region. It improves the accuracy of the model. It really helps make sure that the policies make sense for those regions. If we're looking at trying to introduce a parking policy in downtown Indiana, we need to know where those folks that are living, because they're going to be the ones paying for that, for example. Same thing with some of the travel demand management programs and travel options. So this is just a reminder, again, when we're setting up these models, that the geography was raised, I think, from Minnesota, as well as I think even, well, Li Ming's research is that the geographies are so essential when we're setting up our travel models. And so doing a deep dive on the commuter sheds is a fundamental part that we do day in and day out when we're setting up and looking at VE, so that we can try to get a better sense of trying to maximize the right geography and the right region because as a reminder, this is an econometric model. If it's outside of the model, we ignore it, right? Economics loves to ignore the externalities and those things outside of our area. So if it's not in, it's outside. The last active example that I wanted to showcase was this Baltimore MPO. So a little bit now on the east side of the U.S. We're in the process of just wrapping up. Still, the servers are running 1,500 model scenarios covering 7.4 million people, 3 million households, 3.5 million workers, 3 M areas. So this includes the metropolitan DC area. It includes getting closer to Harrisburg. I think I'm now forgetting my geography there, but then some of the Baltimore and the Baltimore core downtown. And so we've got 3,077 B zones. And this is a beast of a model. And it took a long time to develop the inputs. The really valuable outside that I wanted to communicate to you all is that the model's performing really well. They validated it against their household travel survey data as well as their ABM Insight. It's a TourCast ABM. And the VMT per capita and even the walking and biking trips and the transit trips are showing reasonable levels. So the model is behaving quite well, given the scale of this thing and the urban intensity, the variations in land uses that we're seeing. So I really came out of this initial build process with really a lot of confidence in VisionEval. So I'm glad to kind of communicate that to you all. The other part of the screen here is this right hand. Many of you might be familiar with the multi-scenario viewer, which was this HTML JavaScript. Ben Stabler, I think you were on the call earlier. He was involved in that original creation with Aditya Gore from my team. And that process is great, but it's a little inflexible. And so what we've created now is that we've created a Tableau version of it. And in this one, you can see the evolution. There's like color coding. There's these checkboxes for which measures you want to see in your outputs. And then we're using these pie charts that we're showing the numbers of scenarios that are part of the input process. So we're going to be using this on the 14th and 15th in May in Baltimore with stakeholders to explore these 1,500 scenarios. So it's a very much not a lot of time here to dive into the results, but it's been a really great process so far. Yeah. I'll tell you that later on how long it takes to run those scenarios. As a reminder, this is how this multi-scenario process is set up. This is not for this model. This is for another smaller model, but it basically goes through each of those different scenario categories. Those are those top levers. In this case, we had 5 buckets in Baltimore, and then we had multiple different levels of dimensions. And when you multiply each of the level by the level of change, you get the 1,500. So in this case, we were something like 5, 4, 3, 3, and you multiply that out and it runs every combination of inputs. So lastly, I'm going to turn it over to Tara in a minute, but I'll be presenting at the Tools of the Trade in mid-June. So if anybody's there, it'd be great to connect. We're going to hold a 2.5-hour workshop on VisionEval, where we're going to center, it's going to be kind of bifurcated. First off is talking about how to apply VisionEval for LRTPs. And then it will be the application side where we're going to be using this scenario viewer on the right or something akin to it. We have to deal with licensing and software and whatnot, but we will be exploring the scenario viewers on a handful of examples that we've dialed up. Then we're also really excited to continue to develop the ITHM module. This is the Integrated Transport and Health Impact Modeling Tool. This has been a UK developed process that's been adapted in the US. California developed an R scripted process. To Ted Mansfield, who is now at Streetlight, who left RSG, he really helped us refactor that R code, and we created a module within VisionEval. It benefits from the synthetic population that VisionEval has, and so we're able to get person-level attributes and to estimate avoided premature deaths because of increases in walking and biking and changes in your driving patterns. And so what it really benefits from is a really detailed population sim, output. So we're replacing the population synthesizer within VisionEval with the open source population sim module. And this is that the central Indiana modules are doing this, and that way we're able to roll in the item because it requires that person level details. That VE population synthesis produces only household levels. And so when we need that person level detail, we're using that population sim. So lastly, Tara, I'll turn it over here to you on the beta modules and then carrying it forward. So thanks.
Yeah. So the beta modules I kind of added to Jonathan's slide since a lot of them were actually developed by RSG. That includes an multimodal module, which actually original kernel came through PSU and the research. Prior to their land use work, they had worked on that multimodal that you've heard a bunch about today, building on that built form variables that are available now with that version of the model. Second thing that is RSG has added, we use this in our Oregon transportation plan as a work from home or telework model. Really great to start being able to utilize that and testing scenarios with that. Even more far thinking is a driverless model, looking at, different level 5, just sort of jumping into what if. So a little bit more pie in the sky, but some testing. And then a car share. So we do have car service in the model, but a shared ride service was recently added. So I call these beta modules because they're not part of the standard download, and so they're kind of in other locations that you'd have to download those separately and then call them instead of the traditional modules in VisionEval. So we're still working to kind of get those seamlessly available to folks. But thanks to RSG and PSU a little bit for doing that. Oh, and the other connection I would make is that ITHM work, the health module, because it requires, the beta zones, and in VE state it does not have beta zones. We're actually toying with linking two things here, the land use model, which would maybe synthesize down to the B zones, and then we could apply this module. So anyway, lots of interconnected things here going on. We can move to the next slide, which is just, I'm just so overjoyed here that we are, this is expanded over starting here originally in Oregon in 2012 with Brian Greger building this model, using it on some of our greenhouse gas work, and just expanded here. We've got like over 25 dots and colors, states and localities using the model here. And then I would go further to the next slide. And say, some of those of us have joined into a partnership where we're working with, 9 DOTs and 5 MPOs, where we're, spend a little bit in and out, but since 2018. And so we decided we wanted to pull things together and have been working to shepherd this all along through 2 FHWA pooled fund cycles that were extended and so forth to cover that period. And at this point, given sort of the chaos at the federal level, we are, being told that this is not an option for FHWA to lead this anymore. So we're having to retool a little bit and figure out what our partnership will do to, continue the work here. I think that, what you've seen today, there's really a strong thing. This will definitely go on in some form, and we're trying to figure out how we will continue to pool funds and move forward with that continued development and continued sort of shepherding and community peer sharing. So the partnership activities include, administering to get us together to talk community practice at the bottom, but also more technical maintenance of the tool. If an R script or a new R version comes out, you need to update that tool. So we're trying to do that maintenance, and Jeremy Raw was mentioned quite a bit in the chat and so forth. He's been our key driver in the car that is the VisionEval pooled fund, and he is retiring as well with these changes a couple years earlier than we thought. But anyway, so we're trying to maintain that level of work and upgrade our models and maintain them here for the community that's broader than the partnership to continue to work. And I'm super excited here, especially to bring in the research realm and connect those dots. That I think the tool has a lot of capabilities that most of the work is done. And if you pull out a piece of it, you can do some research and maybe plug in, like that bike module or land use component. And the rest of the stuff's already kind of there. So great. I see Jeremy responding in the chat as well. Okay, so next slide. Yes, so in addition to the tools of the trade that Jonathan mentioned, we're also been awarded a session at the Modeling Mobility Conference, that Zephyr conference that Chris at the top of our mentioned is coming up in September, trying to figure out exactly what this looks like, but a key part of it is to understand why another tool, right? And I think we've seen here today some of the complementary pieces. It's not a replacement for your travel model. It does really other things. And so that would be the focus of this discussion with some applications and panel discussions. All right, that might be wrap up. Yes, and so here I've just, you can't all read these all right now, but this will be part of the information that gets coded on the website of some resources, both at the national level. The VisionEval.org is your access to all of those, but I've highlighted the user's guide, the code on GitHub, and then a number of things I've found particularly useful for sort of starting up, a quick understanding of modules and how they work, what inputs can you actually change, and the file summary of all the files if you just want to know those. And then at ODOT, we have a short couple-page flyer, and you can learn more at the TPOW Tools website. With that, I'll wrap it back, send it back to Chris to wrap up here.
Okay.
Thank you.
Thanks, Tara and Jonathan. This is great. In my excitement to be a good moderator, I blew through most of my conclusion slides, and so we do have a couple minutes for questions here. And I think maybe Jonathan, do a quick dive into the 1500 scenarios and how you all sifted through those scenarios, or plan to sift through all those scenarios. I think there's a few questions around that topic, I guess. So.
Yeah. Well, it's been a good learning for us. It's about a 5-hour model run, and so we've needed to split up the server runs. We've had Baltimore take half the runs, RSG take the other half. We're splitting it between different servers, and then we're merging it all back together at the end. So it's been a computational exercise as well as a useful exercise. So. Yeah, right now though we've developed some initial prototypes. That's what that Tableau is using, and anybody who's used the multi-scenario viewer, it's really what we call a goal-seeking process, where you get to put all this 1500 scenarios together, and you're only mining a handful of measures. And so in this case, I think we're taking 20 measures. And by selecting any one of those measures or several of them, you can say, I want the highest of this measure and the lowest of this measure. And then what you do is you get to find out which scenarios got you those two options, those two results. And you can then play with any of those types of combinations with those 20 different outputs. So it's a shift in process where we develop this range of possible futures, and then looking at the outcomes, we can say, well, which inputs actually got us to those desired outcomes. So it's a scenario planning shifted, just flipped on its end.
Mm-hmm. Very cool. One more question. If anybody has another question, please post it in the chat or feel free to raise your hand. Otherwise, I am going to send us home. So thank you, all of you. The presenters were fantastic. Thank you to the audience, to the attendees. By my count, I think we had 54 attendees at our high point. And so I hope this was both educational as well as inspirational. I hope for those of you that are not part of the VisionEval family, this gave you something to think about in terms of joining the family. And so again, thanks everyone for a fantastic session, and we hope to see you all again sometime later this summer, where we're gonna talk freight. So